Hi everyone, welcome to NetGate Chemistry. So today we're going to solve some of the previous year questions of polymer chemistry part which are being asked in CSIR net exams. So the first question which we are going to discuss is the correct expression for the product Mn and Mw, where Mn and Mw are number average and weight average molar masses respectively of a polymer is. So basically we have to find out the product of Mn and Mw. So it is specified that Mn is the number average molar mass. So we know the formula for Mn, which is sigma Ni Mi divided by sigma Ni. See, in polymer chemistry you just have to remember the formulas and you will be able to solve the questions. So Mn is equals to this, and the formula for Mw is sigma Ni Mi square upon sigma Ni Mi. So we have to find out the product of these two. So basically Mn multiplied by Mw will be equal to sigma Ni Mi upon sigma Ni multiplied by sigma Ni Mi square divided by sigma Ni Mi. So these two terms will cancel out each other. So we'll be left with sigma Ni Mi square upon sigma Ni. Now we all know that sigma Ni can be written as capital N. So what we'll get? Mn into Mw. Their product will be equal to sigma Ni Mi square upon N. Also we can write it as N inverse. When we take this N to the numerator, it becomes N inverse into sigma Ni Mi square. So this is the answer. So it matches with option B. So B is the correct option. So now we'll move on to question number 2. So now moving on to the second question. This question was asked in June 2011 exam. It says that there are several types of mean molar masses for polymer and they are dependent on experimental methods like osmometry, light scattering and sedimentation. We have to find out the correct relations. So for osmometry is used to find out which type of mean molar mass, that is Mn, right? Number average molar mass. Now the light scattering experiment is used to find out Mw, weight average molar mass, and sedimentation process, this is used to find out Mz, right? So these all we have discussed. I think 4 or 5 we have discussed in the polymer chemistry part. Basic, you can find out the playlist of polymers in the playlist section. There are 3 videos, out of which you can find in, I think, first video itself you can find out the various methods. So you just have to memorize them. So the correct option is option, see, for osmometry it is Mn for 1. So these two options cancel out. Light scattering is for Mw, second is for Mw. So option C is the correct option, and Mz is for sedimentation, right? So option C is the correct option here. So with this we will now move on to the next question. So this question was asked in June 2019 exam. It's a recent question, very recent question in fact. So it says that the reaction rate of a self-catalyzed polyesterification reaction is given as this. If M naught is initial concentration of hydroxyl and carboxyl monomers, then the degree of polymerization is given by. So basically we have to find out the degree of polymerization, or you can say the expression of this N. So you should know the formula for degree of polymerization, that is equals to 1 upon 1 minus P. Here P represents this P, capital P represents the fraction of polymer units undergoing polymerization process. So P basically is representing the fraction of polymers which are undergoing polymerization. And also if you look at this expression, from this expression you can find out the order of reaction. Order of reaction will be 2 and here it's 1. So 2 plus 1 order is 2 plus 1 order is 3. This is the order of reaction, right? So if the order of reaction is 3, then for third order reaction we have the equation 1 upon m square is equals to 1 upon m naught square plus 2 kt. This is the equation for third order reaction. Now here m naught is the initial concentration of the monomer and m is the concentration of monomer which is left after the reaction after certain time t. So now what you can say is that m could be equal to m naught minus x. So here x will be what? X will be the monomer which have undergone polymerization, right? So the total number of monomers minus the number of monomers undergoing polymerization will give the value of m. These will be the monomers which will be left after polymerization after time small t. So now what's next? P will be equal to x upon m naught, right? The fraction will be equal to x upon m naught. X is the monomer undergone polymerization divided by total number of monomers. So that will give you the fraction, right? The fraction of polymer units which have undergone polymerization. How you can find out that? The fraction undergone, the monomers undergone polymerization divided by total number of monomers. So now from here what you can do is you can find out the value of x, that will be equal to m naught into p. Now if you put the value of this m naught p, that is the value of x, if you put this value of x in this equation, what you will get is m is equals to m naught minus m naught p. I have simply substituted this value of x is equals to m naught p in the above equation. So I have got this equation. From here you can take m naught common, so you will get m is equals to m naught into 1 minus p. Take it to be equation number 2 and this standard equation, this was equation number 1. Now you can put the value of this m in equation number 1. Simply putting 2 in 1, what you will get? 1 upon m square. Instead of m square we are going to write this whole square. So it comes out to be m naught square into 1 minus p whole square. That will be equal to 1 upon m naught square plus 2 kt. Now we have to simply rearrange 1 upon m naught square. Take this term here and take 1 upon m naught square common. So you will get 1 upon m naught square outside, 1 minus p whole square minus 1 is equals to 2 kt. Now take this m naught square to the right hand side. So you will be left with 1 upon 1 minus p whole square minus 1. This bracket will remain onto the left hand side and this 1 upon m naught square, it goes to the right hand side, so it was divided here, so it will be multiplied here, right? So this is what we get here. Now we know that n is equals to 1 upon 1 minus p, right? We have written it here also. So substituting the value of 1 upon 1 minus p as n here, so we will get n square minus 1 is equals to 2 kt m naught square. So here if you take minus 1 to the right hand side, you will get n square is equals to 2 kt m naught square plus 1. So this will be the final expression which you will be getting. So this matches with which of the following? C. Option C. It matches with option C. So C is the correct option. So I think so far that's it for this video. Thank you so much for watching.